we are Project 20365B, the self-solving Rubik's Cube team. I'm Kenji, the purchasing lead.
And I'm Mitch, the project manager.
I'm 1J, Confluence webmaster.
Caleb, lead software engineer.
Matthew, the lead hardware engineer.
Josh, the facilitator.
The Rubik's Cube has more than 43 quintillion possible combinations and has become a sensation around the world since it was invented in 1974. The goal of this project was to design and create a 3x3x3 Rubik's Cube with inner mechanical capabilities to solve itself automatically in under a minute.
Our electrical subsystem of our Rubik's Cube consists of six stepper motors, 6 motor drivers, and 6 optical encoders for each face of the cube. Controlling all of these peripherals is a Raspberry Pi Zero, giving algorithmic commands to each motor.
Before starting to test electrical components, we created an electrical schematic as seen on the middle. It is to verify proper pinouts and to verify exactly what pins we should be using based on our own testing. Initially, we were planning to mount a breadboard into a cube core. Eventually, we changed from a breadboard to a prototyping board for reducing the space of the core.
To test the cube, we started with an open-source Python-based Rubik solver and overhauled it to include GPIO testing. This way, our system and Rubik's Runner.py, our program, can successfully take input from an encoder in order to modify the algorithm's perception of the cube, run a solving diagnostic to find the optimal solution for the cube, and send the correct moves to the correct motor to solve the cube.
The mechanical part was mostly done on CAD, then 3D printed, which consisted of 8 corner pieces, 12 edge pieces, 6 center pieces, the inner core, and the base. Most of the parts were good to go right away, but some required extra modifications that were done in the Mechie machine shop.
The project is partially successful. We had space concerns in the core structure, which couldn't fit all the electrical components. The cubes printed were also too heavy for the motors to turn the faces of the cube.